Hi, welcome back to my channel, Geeking Jadi, and I'm here to talk and try to explain as much as I understand the super shocking news about the recent backdoor in many Linux distributions, although they haven't reached our major server distributions, but you can see them in the bleeding edge ones like Arch, Debian Seed, and these kind of distros. Rolling ones with a bleeding edge software. This is discovered and explained by Andres Front, if I pronounce correctly. The fun fact is it is discussed in Mastodon. Another guy talked about it in Blue Sky. So X or Twitter is losing its edge. And we like it. Not anything against X, but having more options is better. Having a Fediverse is much better, and Mastodon is our choice. Anyway, the news is about a backdoor in many Linux distributions, or possible, and it comes from the XZ library. This comes from Andres. He says, I accidentally found a security issue while benchmarking Postgres changes. He was checking the speed of Postgres runs and found out there is a problem somewhere. He was benchmarking different versions, different configurations, and found out somewhere it suddenly becomes slower. Later he says from 0.3 seconds to 0.8 seconds. This is huge, difficult to observe for normal human beings, but he's an expert and he was using a software to check the performance. He went forward and found out this is not about PostgreSQL. It is about the SSH connection. What he found was when he was trying to SSH from one system to another, it normally had to take this. But on a Debian Seed, it was taking this much. Why? He started to explore more and wrote his finding in the OpenWall email. OpenWall is where many security experts discuss the security of their open environment. This is from 29th of March. He says, I found some odd symptoms regarding liblzma. This is a compression library, part of the XZ package. You know about compression. When you have something, you compress it, it becomes much smaller, and you can make this larger back and get back your main stuff. SSH has nothing to do with the compression. So what is going on? First, he says, I assume this should be a problem in Debian because I can see it only on Debian Seed. If you are familiar with Debian, you know that Seed has the latest software. It's like a rolling release. But he says afterward, I found that this does not come from Debian. This is coming from XZ library. Although when checking the codes in XZ GitHub, which is not there anymore, it's disabled, I cannot see these problems. Very strange. So he found out that this solely happens in the distributed tarballs and not the source code itself. Again, it's becoming more and more strange. This was one of the, I wanted to say most complicated, but best planned supply chain attacks, some people claimed. In the main GitHub of XZ, there is no problem. If you get the code and compile it yourself, you won't see any problem. But when GitHub creates distribution tarballs, the final product, the problem is there. How can this happen? For example, he points out to the Debian's package which is shipped. This is a M4 file. This is the build to host. So this is an M4. M4 is a language created by Kernighan himself, if I'm not mistaken, used in the original Unix environments. Now it's in many places. It's in AutoConf system. So you write a configuration, kind of a program. It's a program. You write a program, and this can be used to create distribution specific builds or anything you want with the autoconf. It's a very, very versatile system. But he says that I observed this. If text x, some variable, is not equal to x, so if some variable is there, has a value, do this. What it does, it checks for something, does some replacement, evaluates something, does something. It's kind of cryptic. Other lines are not like this. Other lines are much easier to understand. But cryptic things have not started yet. This is a very complicated attack. He says, I observed this, and this line is not in the upstream source of the build to host. So he goes forward, points to some codes. These codes are not there anymore. This repository has been disabled, although this is related to the very, very infamous XZ package for compressions. This says this injects an obfuscated script to be executed at the end of the configuration. And it's obfuscated. So a normal human being cannot read it. What does this mean? When you write your program, you say if blah blah for blah blah, print this. What happens if you replace if with something strange, with a define, if you change your for, if you rename your variables to strange things? After some time, normal people won't be able to understand your code anymore, but a compiler can. So there are even competitions. Check for obfuscated C competition. You will see lots of fun codes which are impossible to run, but compiler can run it and create fun outputs. So somewhere using that line you just saw, an unreadable code is added to the XZ library. What is that? It goes forward. He has tried to follow what is happening. This ends up to this one. At the end, this happens to the code. You can see it's unreadable, does strange things. And it has a hello word here. And at the end, it leads to the attachment which is here in injected txt. This is the injected txt. See, he creates some values. This is steps and steps and steps of clearing the code, making code more readable. What happens is it's a program which is added to the code. Does many things. For example, here it checks to make sure that the architecture of the computer running the code is a normal 64-bit computer, not an ARM or something, for example. Or later it checks to make sure that the system is using GCC compiler. And also it checks to make sure that this is using a GNU version of linker. You know, you write your program, you compile it to something, but this using different libraries. So you have different libraries here, different parts of functions which you will need. For example, if you are creating an SSH connection, you need to sign your code somewhere, sign your signature somewhere, check your signature somewhere. Those are coming from different libraries. So you write your own program and you say use this library, and use this library. Now you can call this function. That is the work of this linker. And it checks to make sure that you are using GCC and you are using the GNU linker. And then does all of these. Still not very easy to understand, very difficult to understand. And you can see that it loads the libraries from liblzma and everything. So what happens later? The Andres Front, person who found this while working on Postgres, is an expert on databases, has linked to many places. These are not here anymore, but he have shown the most important parts. He says the point is on the version 5.6.7 and 5.6.1, we have these two lines, which adds what I showed you to the XZ library. The strange thing is people started to check what is going on, and it's like a mystery or a thriller. A user called GiaT75 has done this. How can someone add something to the library as important as XZ, which is running on practically all of Linux distributions? How can someone inject some mysterious unreadable code and no one blinks an eye or objects to it? This user joined GitHub on 2022. Did some contribution to another compression library. It was accepted and it contained some strange code with some prints. Later it was removed. Then he approached XZ project. He started contributing here. Another person started pushing to XZ people that you need to add more developers. You have to add more developers. You have to add more developers. And this is a new guy who's working on this project. So let's add him as a developer. So now he has access. Even his email is regarded as one of the main contacts for XZ. And now when he adds some unreadable obfuscated code to this project, no one needs to check it. He just adds it because he is trusted. So that's how code is added on version 5.6.0. But what does this code do? It's very difficult to reverse engineering something like this. The writer of the article says the committer, we know, GiaT79, is either directly involved in these attacks or there was some quiet, severe compromise of their account. This is very unlikely. Other people tried what he has done and he was suspicious. Also, people saw some changes on the code making parts of it more unreadable from this user. So it seems he knew what he was doing. His name is kind of like Jody. I met the guy. So, and also in some parts, people started asking him questions, not accepting him as the contributor, and another user suddenly appeared, defended him, and then disappeared. So this, for me at least, this looks like a very, very planned attack. It affects some of the systems, and our friend have found it on the open SSH servers. As I've told you, on a normal system, the time for the connection, if you know about SSH, it's a protocol. I'm in this machine. This is my server. I connect to my server using SSH. I issue commands here, see the results on my terminal, issue commands and see the results. It's like sitting behind that specific terminal and working. Practically all the Linux administrators are using SSH to do their everyday job. It's a secure shell on a remote machine. So what he saw was, on a normal system, establishment of this connection, which requires some key exchange, signature verification, and these kind of stuff takes 0.3 seconds. But on a Debian seed, which now we know that using XZ library version 5.6.0 or 1, this was taking much longer. He also tried to examine where this happens, and he found out that this only happens when the term environment variable is not set. We are using default terminal. arg0, which is the program being run, is user spin sshd. Also, ld debug and ld profile are not set. You can use these variables to profile and debug programs. When you are doing this, you're checking line by line what is happening, checking your logs and everything. So when in this state, this program doesn't do anything. Langs need to be set, don't know why. Some debugging environments like RR appear to be detected. So if you are debugging the program, and in some cases with GDB, which is a more common debugger, this doesn't do anything. So it's very difficult. As soon as you start looking at it, it doesn't do anything. Acts super normal. In other cases, what it does. This researcher have found it using perf with record. So he's observed that when the backdoor is working, it's taking much longer. It's replacing ifunc resolver's CRC32 resolve and CRC64 resolve. So what is happening is when you are running your program, it calls different functions from other libraries. This should be resolved. Where is this? These are saved in some tables and different places. This is manipulating these ones, looking at this, replacing this with its own backdoor versions. It changes the symbol tables in memory. It's a slow step, and this is the one which is detected. There is one function, it's called RSA public decrypt. It's called decrypt, but technically, if you know about it, it doesn't decrypt anything. It signs your verification. It verifies your signature, and it is the PLT, which is the procedure linkage table. We have another thing, which is GOT, which is global offset table. These are the places where your linker looks into to find other procedures. This manipulated one was replacing these. So the function CRC resolvers you saw above are, their task is finding these functions and creating a table. So whenever in your program you want to call this, you look into that table and say, okay, I'm calling this, let's run this, and then return back to my own program. What is happening here is the broken XZ is loaded by SSH, although it is not needed, but it's a very fundamental library. So when you run SSH, this runs. This is manipulated and backdoor. So when you run SSH, you are practically running this specific version of the resolver. So this resolver replaces the RSA public decrypt function. When you want to run the SSH, RSL public decrypt is used to verify that you are the person you are claiming you are. So this is manipulated. When you run SSH, XZ is loaded first because it's a fundamental library, or whatever reason, I haven't checked exactly into it, but it runs before any other thing, most of the things. It changed the resolver. So now the resolver manipulates your table and says RSA public decrypt is here instead of the main one, which is here from your library. So now when SSH runs the RSA public library, because this has run beforehand, uses this one, which is the backdoored one. It signs one specific signature. Now your SSH accepts whatever comes from here and then goes through the normal path, and this works. So this is in the middle. SSH calls RSA, but RSA is already manipulated using the XZ library. So practically you are using a fake RSS public decrypt, which signs your specific version, your specific person, and then calls the main one, and this works. So it's transparent for you, but you have one extra trusted party here. Very, very, very strange. This is the flaw he describes. You are calling this, but practically first you are calling a bad version from here, and then going back to the one from libcrypto. He reported the bug to the distros because obviously he didn't trust the XZ itself, and later other people started adding more information. For example, Filippo Valsorta on the Blue Sky. As I've told you, it's fun. It's a Mastodon, Blue Sky, and a Fediverse. He says, I'm watching some folks checking this. and he has this important piece of information that this new hooked RSA public decrypts verify a signature on the server host key by a fixed key and then passes the payload to systemd. So you run SSH, SSH goes through, calls the fake one, he accepts whatever comes from a bad actor and sends it to your system call. So practically this is not a attack on your authentication. It's a RCA attack, remote code execution. Practically someone with this key can send whatever to your system call. Very, very, very strange attack. We can be sure that this GRT75 comes, we can be sure, I think so. You cannot be sure, but comes from a long plan, creating an account, getting trust on one of the important libraries which is installed everywhere, and then adding something to it, and then disappearing. Now the whole XZ is disabled. What they did was, this was the affected version, and they reverted back to 5.4.0 and checking whatever comes from this user. But for sure, this actor can have different users, countries will start doing this kind of stuff, but we are in a free software world. Important quote from Eric Raymond. This is called Linus Laws, but this comes from Eric Raymond. It says, given enough eyeballs, all bugs are shallow. When you have enough eyes watching to all the code, what was this? It's like a room like this. When you have enough eyeballs watching to your code, like testers, code developers, programmers, code reviewers, at the end you will see all of these bugs. This happens because we are on a free and open source software world. Okay, someone can come to the XZ project and GitHub, get trust, do something bad, but on the other side there are other 1,000 eyes watching the project. So this is a new era. For sure we can be completely sure that the same thing is being happened with other projects. Government actors, bad teams, whatever, are trying to send people to the projects, get trust, have trusted developers. It's good to pay, 100 good developers in your country, and they will work on important projects and get trust and everything for the day. But on the other side, the good news is this is free software. The issues will be seen because exact same thing can be happening with any closed source. It's enough to send some employee to blah blah company and compromise their OS, and nobody will see this. Now it was possible to check the code. And on the other hand, it's a call for maybe a change. There is a joke which shows a very huge system and it all relies on one brick here. And this is your blah blah developer working on spare time on a library. So it's time to give more support to these people who are working on free software. If a free software is being used in a Fortune 500 company, it's good for that company to pay the guy or gal or what. Anyway, have fun. I'm glad that we reviewed this. We will continue watching it. Some fun things may happen again. Dangerous fun. I repeat, nothing happened for major Linux distributions. This only appeared in the very bleeding edge distros like Arch Linux, Debian Seed, and these kind of things which people use the latest ones. Normally, for example, your Debian may ship with 5.4.0, and this 5.6.0 may come only to Debian Seed. After 6 months, 1 year, it may go to the stable distro. So you are safe if you are using a stable distro on your servers. If you are using Arch or something, do an upgrade and it will upgrade this broken one with the older one. Have fun, enjoy technology, and learn everything.